Welcome to This Explainer. Today, we're cutting right through the industry hype to nail down exactly what an AI engineer is, and honestly, why this specific role is just completely dominating the tech landscape right now. If you've been watching the job market lately, you've probably noticed that artificial intelligence isn't just some optional, nice-to-have skill anymore. It's literally the engine driving global innovation. But let's be real, with all the noise and buzzwords out there, figuring out what it actually means to build a career in the role of artificial intelligence engineering can feel super overwhelming.
And because AI is transforming literally every sector, it's so easy to get tripped up by job titles that sound, well, exactly the same. I mean, data scientist, machine learning engineer, AI engineer. They all just work with data and AI, right? Actually, no. Here's the secret. They demand completely different mindsets, different daily responsibilities, and totally different toolkits. So many professionals jump into the role of artificial intelligence engineering without really grasping these differences, and man, they just quickly end up feeling totally lost.
So here's our roadmap for this explainer. First, we'll officially meet the AI engineer. Second, we'll look at the 2026 AI tech stack. Third, we'll dive into MLOps and managing model drift. Fourth, we'll talk about building autonomous AI agents. And finally, number 5, we'll look at the real-world industry impact.
All right, let's kick things off with Section 1, Meet the AI Engineer. I absolutely love this analogy because it brilliantly illustrates the division of labor across the AI landscape. It is hands down the simplest way to wrap your head around how these roles collaborate. Think of it like this. Data scientists are the explorers. They're deep in the statistics, experimenting and researching to design the core brain. Then you have machine learning, or ML engineers. These are your builders, focusing on the pipelines and scalability to make sure that brain actually works reliably out in production. But the AI engineer, they're the product creators. They are the ones taking those models and building the full intelligent vehicle, weaving everything into end-to-end applications that solve actual real-world business problems.
So it really all boils down to how your brain works, your mindset. If you're someone who just loves mathematics, probability, and uncovering those hidden insights buried in raw data, then you know what? You're likely a data scientist at heart. But if you find yourself leaning more toward practical implementation rather than pure research, like if you want to get your hands dirty with APIs, build cool AI-powered features, and deliver complete automated software solutions right to the users, well then you, my friend, are an AI engineer.
Moving right along to Section 2, the 2026 AI tech stack.
Now, what's truly fascinating about the current landscape is that the absolute bedrock of the industry is entirely Python first. I mean, every serious AI framework, every major large language model SDK, every deployment tool you'll want to use right now, Python first. And I don't just mean Python friendly, I mean Python first. If you're coming over from another programming language, this is your absolute non-negotiable starting point before you even think about touching an AI model.
The crucial takeaway here is that modern AI engineering has really shifted. It's heavily focused on API integration and validating structured data now. By 2026, the role of artificial intelligence engineering is definitely not going to be about the purely academic exercise of training deep learning models from scratch. No way. It's all about integrating incredibly powerful, pre-trained models. And a huge piece of that puzzle is handling structured data. You're going to need tools like Pydantic, because think about it. When you ask an LLM to give you structured data back, you absolutely need robust schema validation so the response isn't just totally malformed garbage. The industry is really valuing depth over breadth these days. Knowing one framework deeply and knowing exactly how to deploy it using Docker on a single server is going to be far more valuable to you than having some superficial understanding of a dozen different tools.
Okay, let's jump into Section 3, MLOps and managing model drift.
So, standard software engineering relies on DevOps to version code, right? It's a very deterministic process. You put in the exact same source code, you'll always get the exact same build-out. But machine learning operations, or MLOps, is a whole different beast. It's way more complex. MLOps has to govern this sort of holy trinity of code, data, and models, all at the exact same time. Because training models is stochastic, it relies on ever-changing data, you have to account for these non-deterministic elements. That means building continuous training pipelines that honestly just do not exist in traditional software development.
And that brings us to a massive, unique challenge in this space: model drift. Unlike traditional software that just basically stays exactly as you wrote it until the end of time, AI models actually decay. It's true. As real-world data distributions shift over time, say consumer behaviors change overnight or some new internet slang emerges, the model's accuracy starts to degrade. And this happens even if the underlying code hasn't changed one single bit. So to fight this, you absolutely need automated continuous training pipelines to spot that drift and instantly trigger retraining.
And because of this exact phenomenon, get this, a staggering 88% of AI initiatives fail to ever see the light of production without a dedicated MLOps strategy. 88%, that's huge. If you don't have the infrastructure in place to monitor for that model drift and manage the constant influx of new data, your shiny, intelligent system is just going to completely fall apart the second it hits the messy reality of the real world.
Which leads us nicely into Section 4, building autonomous AI agents.
Now, as an AI engineer, you aren't just going to be building basic chatbots that answer simple, repetitive questions. Oh no. You're going to engineer autonomous software agents that can actually plan out steps, use external tools, and collaborate to achieve really complex goals. For example, using libraries like Crew AI, you can build a whole multi-agent system. Imagine a 5-agent content team. You've got one agent out there doing the research, another analyzing what the audience needs, a third one actually writing the content, a fourth acting like a strict editorial director for quality control, and a fifth tweaking everything for SEO. It's literally about orchestrating AI to execute these complex, multi-step workflows totally on their own. How cool is that?
Finally, let's wrap things up with Section 5, real-world industry impact. According to a recent McKinsey AI workforce report, AI-related roles have absolutely surged. We're talking a 21% jump across all job postings between 2018 and mid-2024. The message from the market here couldn't be any clearer. Companies everywhere are desperately searching for professionals who can cut through the hype and actually sit down to build these smart, scalable systems that solve real, tangible problems.
And this massive demand translates directly into serious career mobility. To put that into perspective, 86% of specialized bootcamp graduates are jumping straight into the tech industry, while the other 14% are taking these highly sought-after skills and applying them in entirely different sectors.
And wow, those other sectors are seeing some massive transformations. Over in healthcare, AI engineers are deploying systems to analyze complex medical images and predict patient complications before they happen. In finance, they're building algorithms to detect fraud in real time. In manufacturing, they're powering entire smart factories using predictive maintenance. Across the board, executing this technology effectively can slash operational costs by anywhere from 5 to 20%. So, it really isn't about AI replacing jobs, it's about AI engineers creating the very systems that are transforming how literally every industry operates.
AI careers are incredibly powerful, for sure, but really only when you choose the path that actually aligns with your unique skills and mindset. So I want to leave you with this final thought to kind of chew on. As the world rapidly changes around us, will you be the one to analyze the data? Will you be the one to optimize the pipelines? Or will you step up to engineer the complete intelligent vehicle? Thank you so much for joining me on this explainer today, and I really hope this gives you a much clearer roadmap for your future.